Hi everyone. Welcome to our talk. My name is Rishabh Misra and I work as a senior machine learning engineer uh, at Attentive. It's a late stage startup currently in San Francisco Bay Area.
Hey everyone, my name is Jigyasa Grover, and I'm currently working as a senior data scientist at FAIR, based out of San Francisco. And today we'll be talking about how we can sculpt the right kind of data for our machine learning models. The last couple of years have seen an immense growth of machine learning in multiple domains, from influencing our shopping lists to cars self-driving themselves around the town, especially in SF. When you sit in a driverless car, it feels the future is here. Unquestionably, our machine learning is the most used and the most abused subdomain of artificial intelligence presently. It is being wielded in improving healthcare and advancing warfare, in generating automated summaries of product reviews, in creating music and meaningful lyrics, to synthesizing pictures and videos of non-existent people, and so on. Regardless of our fascination for it or for our loathe for it, it is influencing our decision-making power and is dominating our lives heavily. To describe, enabling computers to learn on their own is what encompasses machine learning. The power of spotting patterns on their own without the requirement of programming is the biggest edge these decision-making systems have over the others. Researchers keep traversing unexplored territories of machine learning, whereas, according to experts and businesses, they have just seen the tip of the algorithmic iceberg. According to Next Move Strategy Consulting, the market for AI is expected to show strong growth in the coming decade. Its value of nearly 100 billion US dollars present is expected to grow 20-fold by 2030, up to nearly 2 trillion US dollars. And almost 50% of the companies these days have either been exploring or planning to do machine learning in the near future. The number of startups just focusing on machine learning services are seeing a 14-time rate of increase currently. AI adoption grew nearly 2.5 times in 2022 to its adoption rate 5 years ago. And much of this can be attributed to AI being more understood as an inherent tool of optimizing business and operations in 2022. It is less amazingly novel and rather an understood factor of adding value to your business. And 97% of mobile users use machine learning trained voice assistants like Siri, with a 40% search now powered just by voice. Advancement in the software aspect has also led to a projected growth of 120 billion US dollars global sales of AI powered hardware by the end of 2025. And in the most recent advancement, ChatGPT set record for the fastest growing user base, with ever increasing applications right from elementary schools to super specialized fields. So that being, artificial intelligence is the future, right? Is it magic? Well, dominant leaps are leaving scientists, investors, policymakers, business leaders, and the audience bedazzled, hinting that human-like intelligence in machines might be just around the corner. Nonetheless, progress in machine learning has been impressive, but there is a lot of pending explanation and examination which keeps the research going on. So for the art of machine learning algorithms to work their magic, it's important to focus on three key dimensions: well-calibrated data, sophisticated algorithms, and efficient computation. Since we have progressed more from the rule-based approach to a more data-driven approach, it goes without saying that ML algorithms are trained to capture the implicit information from the data that we provide. So in a sense, it's very true that the modern approaches are very data-hungry. Without going into much details, deep learning algorithms, which have many parameters to be fine-tuned, there needs to be a lot of data at hand to come up with somewhat more generalizable models. So in that sense, having a lot of data is the key to come up with good training sets for those kind of approaches. So you can see this is the AI hierarchy of needs. And worthy data collection forms the foundation of this pyramid. of the AI hierarchy of needs, drawn parallel to Maslow's hierarchy of human needs by Monica Rogati, a renowned data scientist and an AI advisor. She puts forward that data literacy, data collection, and data flow, they form the basic needs which must be satisfied in order to achieve self-actualization or nirvana, which in our case would be the ultimate attainment of AI. So I find this pyramid to be very useful to understand, and yeah, feel free to take a snapshot of it. And now coming to the talk of the town, ChatGPTs, LLMs. For those who might be unaware, LLMs are deep learning algorithms that can perform a variety of natural language processing tasks. And they use transformer models and are trained using massive data sets. When we say massive, it could be like hundreds of years worth of textual data, imagine. So hence the name large language models. So in context of LLMs, low quality data can also help in learning generic language capabilities and helpful for simple tasks like text completion. However, when we want very specific applications like question answering, conversations, personalization, or things like generating code for you and debugging, we still need high level quality data set for fine tuning. So in a sense, along with massive data sets, like large quantity of data set, we also need to focus on the type of data that we feed into the algorithm, which has a profound effect on the success of the algorithm. So as Peter Norvig puts forward, more data beats clever algorithms, but better data beats more data. So in a sense, having a lot of data is helpful, but it should be ensured that the quality of data is important too. So let's talk about academia. Like, how can this talk be useful in academia? So core machine learning and data science groups, research groups specifically, are oriented more towards novelty and advancing the field. Many times they weigh this novel idea more than the money-making logic or performance scaling. So in this attempt to work on new problems always, finding collaborators from pertinent domains or seeking funding are just not the only obstacles they face. They also have to look for relevant data. And especially in absence of in-house data, contrary to corporate giants, especially like social media or e-commerce websites, who usually have access to a lot of user data. So if you think from industry perspective, they seldom have problems in obtaining computation power or hiring folks with expertise in corresponding domain or accessing relevant data. They always have access to user data, for example. The challenge, however, comes in scaling up these solutions to massive user base. So any organization that would have a lot of unstructured data at hand in the form of raw logs, they need to develop an efficient data processing pipeline, which is still a very daunting task. So for creating such resilient pipelines, apart from relevant technology, we also need to identify skills to create these meaningful and unbiased data sets.
So talking a bit more concretely, like now we want to learn about how to curate such kind of data sets so that like we can apply machine learning on it. So that's like the theme of this talk. How can we like procure such data sets? So there could be like different approaches to it. But before we talk about it, like we want to highlight 3 of our data sets that we have collected ourselves, so that like we can make like various points to explain the approach. So the first one is the clothing fit dataset that contains fit feedback from customers based on their clothing purchases online and has information about like ratings, reviews, what kind of clothes, what category they belong to, customer measurements. And this dataset was collected specifically to address product size recommendation problem, which is to say that when customers go online, they see several sizes like small, medium, large. Which size should they buy? Then the next data set is the sarcasm data set. Mostly the studies in the past have been utilizing data sets collected from Twitter, but they tend to be like noisy in terms of the labels that they had and the language. So to overcome those limitations, we had collected this data set from two news websites, one sarcastic and one containing like real news. Lastly, there's this news category dataset, which contains around 200,000 news headlines from a US news website. It contains details about the headlines, the tags associated with the story, date it was published. Uh, so essentially, these three are like the main data sets that we'll be referencing throughout our talks to make sure that we are conveying all the points. And they are doing well online on a data science platform called Kaggle, and also being used for various generative AI applications like news personalization, news generation, review summarization, and so on. So circling back to like the approaches to build good quality data sets, there could be like two scenarios. One where we have like a specific problem in mind that we want to solve using machine learning. Another could be like we want to make contributions to the research community, similar to how we develop like machine learning algorithms. Another way to contribute to the community would be building good quality data sets that other researchers can use. So these two are different scenarios, and I'll be talking more about each of them, like what are the challenges and how can we like approach the problem. So in case, let's say we have a specific problem in mind. For example, I talked about product size recommendation problem. Customer goes online, what size of the clothing product they should buy. So if we have like a specific problem like that, we have like a North Star. And in those cases, we can follow along this kind of guided search approach. So the main challenge in this kind of scenario would be understanding what kind of problem we are trying to solve and what are the essential data signals we need. So just like listing down all those pointers. So first of all, we should try to define the problem formally. So to take an example, for the size recommendation problem, the formal definition could be given a user and a clothing product which has different kind of catalog sizes. We want to recommend a size that will fit the online user perfectly. So with that definition in mind, the second step then comes in is identifying the essential data signals we want to collect from our online sources. Uh, so just looking at the formal definition, we can clearly see that there are different attributes we want to collect. One is user ID, other is product ID, third is what kind of size the customer has purchased in the past, and what was the feedback they have given on that purchase. So in machine learning, we want some past historical data for us to be able to like build a model and then predict whether in the future what kind of sizes we want to like recommend to the users. So undoubtedly, like we can collect other type of data signals as well. For example, what kind of product category this product belongs to, or user age, user measurements, but those are not really essential to the problem. Now, third thing is about the data volume. So traditionally, machine learning models tend to kind of work well if we have large amounts of high quality data. So we want to make sure that we are collecting sufficient number of examples for each of the classes that we have. Uh, there could be like some transactions which are not really helpful for the problem that we are trying to solve. For example, let's say a website that doesn't have enough customer reviews, or a news website that doesn't have archive of old posts. So if we don't have enough historical data, we won't be able to train like a machine learning model uh, and solve the ultimate problem that we are aiming at. There is one caveat here, though. In case of like generative AI models, recently we have seen that they are good in few shot learning, so they could work well even if we have, let's say, a handful of examples, but they have to be like higher quality. So if you are trying to apply like generative AI applications, it may be fine to have handful of examples, but they have to be like very high quality. Now, this is like the second scenario where, let's say, we want to make like a contribution to the research community. One way to do is through like ML algorithms. This is like a new paradigm that is coming in, that where we can make contributions using data sets which others can utilize to solve interesting problem. So for this kind of scenario, now what is like the main challenge? Here, the main challenge would be the ambiguity. Like we don't know what essentially we want. So we need to like structure our search somehow, and we'll be like providing some pointers regarding that in our talk. So now, so first, the most basic thing like we want to make sure is the data set that we are trying to collect solve some interesting problem. So to take an example of news category data set that I introduced, that wasn't collected with having any specific problem in mind, but we wanted to make sure still our data set is able to address some fundamental problems. To take an example, if we train a classifier on news category dataset, we can identify what kind of writing style a particular text has. It could be political, it could have like a humorous tone, it could be like sports related. Uh, our data set could help in identifying like the writing patterns, and most recently, like other researchers have been using this data set for like various generative AI applications, like generating personalized news or summarizing news given, let's say, a text, piece of text. So at the base level, like we want to make sure that we are solving some interesting problem. So after we have identified the interesting applications, like we want to make sure that we have sufficient data around the problem that we are trying to solve. So we might know, like in if you're trying to like apply machine learning, feature engineering is like a major part of the process, and we can't do feature engineering if we don't have sufficient metadata associated with the core signals that we are trying to collect. So that's why like we want to make sure that we have enough metadata, and to take an example for clothing fit data set, we had metadata around like the brand of the product, or the type of the fabric, and customer measurements. Now, lastly, the data volume requirement applies here as well. We want to make sure that we have big enough data set, but here it is slightly relaxed because we are not restricted by like a problem definition. So we can try to like mold our data set based on whatever is available online. For to take an example, in news category data set, we have uh, a category which just has 100 news articles. Maybe that is not enough to kind of train like a reliable classifier. So we can just like remove all those instances and only keep categories which have sufficient number of examples. Um, Lastly, we want to make sure that what we are contributing is something unique. Like we don't want to like copy whatever is already available online. So this is similar to how we like contribute like ML algorithms. We want to make sure there's novelty, so that like we are furthering the research in the community. So we always want to make sure that we are not copying someone else's work. Uh, yeah. Now, yeah, Jigyasa can take over for
So,
data extraction.
sure. So I think we've talked enough about like how to plan around where to collect data from, and we should now switch gears and talk about the extraction process a little bit. So we can just walk you through the different tools that could help you facilitate the data curation quest. So they're not necessarily the only tools available, but these are the ones that we've had experience with. So feel free to use any alternatives available if you feel they add more value. So the first could be Chrome and Chrome WebDriver. They are Chrome, as you know, is a popular web browser, and it can provide an excellent tool for inspecting, any particular website's raw code. For example, if you're planning to, extract some data from like an e-commerce website or like let's say social media, just to create a public data set. And then WebDriver is an open source tool for automating testing of web apps. And then is Beautiful Soup, which is a Python library widely used to pull data out of HTML and XML files. And it can unlock the ability to navigate quickly and modify the HTML tree structure that we have. The third tool that we kind of used was Selenium, which is a widely used portable framework for controlling web browsers through programs. And it can help you automate tasks or perform tasks programmatically, like launching a web browser, clicking on a specific button, entering information in forms, etc. So these three tools make a delicious recipe for the extraction toolkit soup that we have. And websites usually have two different categories of content, static and dynamic. And based on what information you require to extract, you can definitely use those tools. So so when we talk about fixed URL pointing to a static page that remains unaffected by any user actions, that would be more of like a static web page. And we may not be able to use same process for extracting dynamic content, since the contents displayed may not be tied to a URL and they keep changing with the user actions. And that's where Selenium comes in handy. It can mimic actions like click of a button, filling of a form, and also retain the corresponding HTML page. So once we've narrowed down the web source and know the type of content, like static or dynamic, the next step is to work on a sequence of scripts to execute in order to extract the data that we have. There could be many things to consider while considering this aspect. For clothing size data set that we talked about, we had to think about how, let's say the website that we used, ModCloth, was structured, how the products are represented more in like how many products per page are being displayed, how many reviews are being showed for each product, where is all the product related metadata, and so on. So if you're interested in learning more about this process, feel free to refer to our book, which kind of like walks you through various scenarios, and it also gives you a link to Python repository where you can read more about the code as well. And now running a one-off script on a web page is relatively easier. But scraping large-scale data from a web source and making sure it doesn't require much intervention would require automation of scripts. So to do this automation, we can, like Selenium button click and Beautiful Soup that runs without any intervention. So now we've talked about our motivation, the planning process, which Serge, guided or unguided, to talk about, how to think about data sources, like which data source to use, and then also the tools, to do. But we should keep in mind that in order to create like a quality data set, extracting data is just not enough. We have to work on the extracted data set to eliminate any kind of impurities that might have crept in before feeding into a machine learning model. So you can think of it as grooming your data set. We can talk more about some of these grooming aspects in the following slides. So the first would be our data would not help a machine learning model, no matter how sophisticated the model is, if the essential data signals are missing. So for example, if you want to predict what size of a t-shirt would fit a particular user, if you don't know the user measurements or you don't know anything about the user, it's very, very hard to predict because you do not have any prior knowledge about them. So also for that clothing fit data set, there could be reviews that are missing the essential data signals like fit feedback, like if they purchased a size M, did it even fit them? Or what kind of size they purchased if you have no information about them. So the whole idea is we either need to remove these transactions from our data or find a way to kind of produce these essential data signals with the information that we have, a process commonly known as imputation. So this process of excluding values due to their irrelevance, redundancy, or extremity from a data set is known as data trimming. So that was the first thing that you can do to kind of like groom your data set. And when in an ideal scenario, what you would believe, like once you have trimmed your data or like you can just simply build a data set from a single web source like ModCloth. But however, the real world isn't idealistic. There would be certainly circumstances where you have to gather bits of attributes from multiple sources to have a more inclusive, meaningful, and valuable data set. So coalescing these data, the data from multiple sources to provide a unified view is what is called data integration. So we can do integration in two ways. The first one be vertical integration. So recall the dataset that we initially talked about, the sarcasm detection dataset, where we collected data from two different websites. There was The Onion, which provided sarcastic versions of current affairs. So the label for is sarcastic, for example, would be true. However, you cannot just train your model with one single label. So you also needed negative examples for that. For that, we used HuffPost, which kind of like reports the real and non-sarcastic versions of it. To finally create one single data set, we fused the records from both of these, the Onion as well as HuffPost, by appending them vertically. Since the attributes in both sets were similar, namely like the article link, what was the headline, was it sarcastic or not, it was easier to connect them based on the attributes and form a single data set having both positive as well as negative samples. So on similar, that was vertical integration. We also have horizontal integration. So let's consider an example where you have to build a data set regarding cities. So containing fields like state, country, area, population, climate, pollution, civic administration, religion, language, festival, etc., etc. It is highly probable that you would not find one single source containing all of these. You might have to refer to multiple of them. So some attributes like state, country, area, population would be available from one source, whereas information about demographics and culture would be available in different source. In such cases, you would be fusing them horizontally, let's say based on city ID, stuff like that. So this is how you can use a concept of integration, both vertical and horizontal, to create a more unified data set and a more inclusive data set. And coming to data transformation. So there is only so much content that is available on the web that it is impossible to check the correctness of all of it. The content by the publisher, the one who creates the website, like the product name, product size, product description, they can be moderated to a certain extent. However, the content the user posts, like the reviews, what are the language the user is using? Are they using any special characters? Are they using any emojis? What are the values they're inputting in product quality, fit, body measurements, etc. We cannot just blatantly feed them to the model, since they can be very, very noisy. Therefore, it's very necessary to scrub the data set using specific techniques to produce a quality data set, a process commonly known as data transformation. The primary focus of data transformation is to scrub the dataset's raw values to remove any redundancies and correct the language and logical semantics. So some techniques could be handling special characters. Either you could remove them or replace them. For example, you have a smiley or emoji in your reviews. You could replace them with happy so that you know that the customer was happy with that particular product purchase. Handling grammar, using the root word of it, stemming, lemmatization, and so on. Encoding the sizes in numerical order so that you know that small S and M do not technically have a relationship, but 1 or 2 have a relationship, that 1 will always be smaller than 2. So you have to encode the sizes in numerical order. So these are some examples how you could transform your data so that the model is able to understand it, and you kind of like scrub it of the impurities and make it more understandable to the machine learning model. Because coming back to it, a model is only as good as the data kind you feed to it. If we talk more about LLM applications, the generative AI part of it, transformation could involve like addition of additional prompts. Prompt engineering is another one of the most fastest growing area in Gen AI, which people are focusing on. And to give you an example, if you have like a big text and you want to generate a news headline from it, an example prompt could be generate a headline for the following article, and then you give the entire text. So this can help LLMs capture the relationship between the article text and the headlines. So this is what prompt engineering comprises of. I think it is very, very high level view of like what prompts are, but if time permits, we could definitely go more in depth about it. And there are also many Gen AI research work that utilize the data sets that we have created on Kaggle, which are kind of like leveraging it. So if you are interested in machine learning or building your own applications or just getting started with it, do feel free to check out Kaggle for the 3 data sets that we kind of referred here. We also have notebooks associated with them so that you could help and make your own applications about them. So coming to the bottom line, there are many other processes apart from the ones that we mentioned here, before which data can become really ready for it to be fed into the machine learning models that we have. You cannot just simply extract the data, have a data set, and feed it into a model. There are a lot of like feature engineering, data pre-processing tasks that need to be done. And this kind of like brings it to like the workflow that we have. So this is the typical workflow you have for a machine learning model. So you have defining a formal problem definition. So that's how you go about it. And then you develop an intuition of how actually machine learning can help you tackle the problem and the challenges that you have. Like, what is the motivation behind it? You cannot just blatantly say, oh, ML will resolve the problem. Then you source the data that you want to use it in your model and fabricate your own data set. If you cannot source it, you fabricate it. And then you process the data set, scrub the raw values, and perform feature engineering. And then you define the appropriate metrics for evaluation and to measure the success of your intelligent solution that you're building. Post that, you choose an appropriate model and the learning algorithm to address the problem. And finally comes deploying the model, monitoring the predictions, and then maintaining the streams of data. Like once you've trained it is not enough. You have to maintain the stream of incoming data. So that being, focus so far has always been on what metrics can we use to define the success of our model, or what state-of-the-art algorithm should we use, how many more layers can we add to our neural network, should we use LLMs or not. So that has been focus so far, but the idea is what comes before that. There has been very less focus, or the focus is growing on how you can source the data and create your own data set, be it from in-house sources or readily available on the internet, and process the data, because iterating it again, data is what forms the core foundation of your machine learning solution. Andrew Ng, I'm sure you must be aware, the guru of ML and AI. He also posted a while ago that AI systems are nothing but code plus data. And most academic benchmarks and competitions, they've always given you the data and said, build a state-of-the-art model that gives you the best performance. However, we have to start thinking that you can also hold code as static and focus on data. So there are two aspects of it. So far, they've always been focused on keeping the data static and focusing on improving the code or the model that we have. But this is what is called data-centric approach to AI, where you also focus on data and source your data, attach metadata to it, engineer features. So on that end, we have co-authored a book called Sculpting Data for ML, which talks you through and talks and walks you through the entire concept of extraction. As I said, it also links you to the Python code in case you want to build your own very data set and put it out there on Kaggle or use it in your research work. Feel free to check it out. Here's the QR code for it. And as mentioned, what's inside, it talks about identification of data signals, end-to-end process of data collection and dataset construction, overview of tools like Beautiful Soup and Selenium, and synopsis of data pre-processing, feature engineering. And lastly, it introduces you to machine learning paradigms from a data perspective. Usually what you'll see is any book on machine learning, they start with the algorithms and what is supervised learning, what is unsupervised learning. But here, that would be the very end of it because we also want to focus on what comes before it, which is the data. And we're highly honored to have it endorsed by leading ML experts from all across the world, from universities like University of California, San Diego, lead AI advocate at Google, and then senior applied scientist at Microsoft. And we'd highly appreciate it if you could check it out. And that being, thank you so much. We would love to answer any questions if you have, and we'd be hanging around here. Thank you.
Thank you.